Hi everybody, Mr. Rubo here, and today we're going to continue looking at polynomials. So we're going to start with fun facts about polynomials. So between two real zeros of a polynomial, there must be at least one relative max or relative min between. And that's because a polynomial doesn't have any breaks. So if you have two x-intercepts, two real zeros, you either have it where it has a maximum, a relative max, or it goes the other way and have a relative min. Also, polynomials of even degree must have either a absolute global max or an absolute or global min. Okay, and I guess we'll throw the little ends there, and instead of a. And again, that's the idea that because they're even, they're going to ending both facing up or both facing down, which means there has to be something to bring them back to them. So yeah, absolute maximum or absolute minimums. Now, a couple other terms here, points of inflection. So a point of inflection occurs when a function changes between concave up and concave down. Now, it can go either way. So it can go from down to up or up to down. So the key with this is at a point of inflection, the rate of change, which we talked about a few topics ago, of a function changes between increasing and decreasing. Okay, so just to kind of see an example here, we have this graph here. It's a polynomial, and they want us to find any values of x where g has a point of inflection. Now, without knowing this graph like equation, and even without knowing some calculus, you may not be able to figure it out exactly, but you can kind of tell from this graph. So I'm going to go ahead, and you kind of see here this graph, if I think about its tangent lines, because again, that's how we kind of tell. We have negative tangent lines, and then eventually it's going flat to zero. So here we're decreasing. I'm sorry, we're increasing because we're negative, going to positive, and then we're going to be going up. Now, so that means this section of the graph is concave up because it's a increasing rate of change. But when you look at this point, now, you can look here then. Here's another point where rate of change is zero, because that tangent line would be horizontal. Well, to go from a rate of change of zero and then it's positive and it's increasing means at some point it has to start decreasing, which again, if you look here, you kind of draw those tangent lines in. We're positive and we're getting less steep. So it is going to be concave down because it's decreasing. So concave down in this section. Okay. Now the point of inflection, though, is where that change, where it stops increasing and starts decreasing. And again, we would really just estimate it. I'm going to make it a nice point because I actually think they wanted it to be a nice point. It's right there at -1, -1. Okay. But then we also have another concave up part. And it's going to here, right? We have a zero, we have negative slopes, and then we go positive slopes. So we have another concave up section right here. So that means we would have another inflection point. And again, I'm going to assume they wanted it to be a really nice point. It's going to be that point there at 1, -1. So to answer part A, any values of x where g has an inflection point, I would say at x equals -1 and +1. Okay. And again, it's that idea of going from concave up to concave down, or concave down to concave up. All right. So now let's real quick. This part will be fairly quick. So it says for each of the following intervals, determine if the rate of change g is increasing or decreasing. Explains the reason for each using features of the graph. So saying from 3 to 4. And we've kind of already marked this up, so it's really nice. It should be quick. 3 to 4, we are in that concave up part, which means, so concave up in this section, which means the rate of change is increasing. Okay, and there's our answer. Okay, -4 to -3. So we're looking at this interval, and again, it's another concave up part. Even though the graph is decreasing, we don't care about the graph itself, we care about the tangent lines. So that means this part is also, since it is concave up, the rate of change is increasing. -1 to 1. Hey, -1 to 1, those were our two inflection points. This section in the middle we said was concave down, which means the rate of change is decreasing. And then our last section is 1 to 2, which 1 to 2 is, even though it's decreasing, we're in the concave up section, which means rate of change is increasing. All right, cool. So it's really nice to put the concave up and concave down sections in your graph when you kind of mark it up. It'll make your life easier for these types of questions that ask you about rate of change increasing or decreasing. So yeah, thanks for watching. Have a great day.